In this country, air conditioning is a virtual necessity for any occupied building. However, air conditioning systems can have both favorable and unfavorable effects. Favorable effects include comfortable indoor environmental conditions for millions of occupants. In addition, efficient high-SEER air conditioning units and electronic controls now available offer ways to enhance the energy efficiency of buildings, reducing operating cost. Unfavorable effects include air conditioning systems that adversely affect building life cycle cost and internal environmental air quality as a result of water accumulation in unacceptable places inside the system, where it causes corrosion and damage to internal components and other surfaces, which shortens equipment life and allows and promotes the growth of mold, bacteria, and other health-threatening biological contaminants. In air conditioning systems, the only acceptable places for water are the cooling coil, condensate drain pan, and the drain system. All other places are unacceptable. To be effective, air conditioning drain systems must overcome the pressures and airflow conditions created inside the drain pan compartment by the fan. Without an effective drain system, condensate flow is adversely affected. In draw-through systems, as illustrated here, water is blown back into the air handler, and drain pan overflow is common. In the industry, the most commonly used drain seal is the condensate trap, installed on the drain connection as illustrated. It uses water to form the drain seal. In theory, the design and operation is simple. The geometry of the trap is determined by the negative pressure created in the drain pan compartment by the fan. When the air conditioning system is not operating, the trap must retain enough water to effect a seal when operation begins. When the air conditioning unit starts, the trap water rises, negates the negative pressure, and prevents airflow into the drain pan. As condensate flows, the trap is filled, and the water column rises to the level necessary for condensate to flow from the trap. When the unit cycles off, the water returns to the trap, and the cycle can be repeated. In theory, the condensate trap appears to be a simple and economical drain seal. In practice, however, it exhibits so many failure modes that it imposes unacceptable damage and contamination on the entire air conditioning system and the building. Many of these critical failure modes were identified by ASHRAE in their standard 6289R, which discusses drains and drain pans in paragraph 564. What ASHRAE standard 6289R says about condensate traps is quoted as follows. Condensate traps exhibit many failure modes that can impact on indoor air quality. Trap failures due to freeze-up, drying out, breakage, blockage, and/or improper installation can compromise the seal against air ingestion through the condensate drain line. Traps with insufficient height between inlet and outlet on draw-through systems can cause the drain to back up when the fan is on, possibly causing drain pan overflow or water droplet carryover into the duct system. The resulting moist surfaces can become sources of biological contamination. Seasonal variations, such as very dry or cold weather, may adversely affect trap operation and condensate removal. The trap failure modes identified by ASHRAE can be divided into three categories: those due to inherent trap deficiencies, trap design deficiencies, and unwise field practices. Inherent deficiencies of traps include unavoidable and frequent flow blockage, susceptibility to freeze damage, dry and useless at startup in wintertime, and dry and useless on secondary drains. These deficiencies are common to any trap, regardless of the design. Design deficiencies of traps include improper trap depth, incorrect height between trap inlet and outlet, no provisions for priming or cleanout, specifying traps for secondary drains, trap or drain seal not specified, or the inadequate space for installing a trap or drain seal. Unwise field practices include double trap airlock, trap removed, failure to clean trap regularly, failure to prime at startup and wintertime, and leaving the port for cleanout and priming open. The property damage and health-threatening conditions caused by trap failures are commonplace. In this country, millions of air conditioners are equipped with trapped condensate drain systems, a situation which virtually ensures that some buildings will never reach the goals of lower HVAC operating cost and healthy indoor environments. The destruction and health threat caused by failed condensate drain systems are extensive. Conditions like depicted here are common and widespread. The wetted surfaces cause corrosion and provide a fertile growth place for contaminating organisms that result in costly property damage and significant health threats. The cause of these conditions are not readily visible to the building owner or manager, so the need to address the situation may not be apparent. Typically what they see during operation are units like the one shown in these photographs. Only when the cabinet is open can the damage be revealed, as shown in these photographs. Traps for drain systems in all shapes and forms are available from supply houses and field fabricators with little or no knowledge of pressure conditions and condensate flow rates. This chart shows some of the types of traps available. Some are more prone to failure than others, but all, including the best possible geometry, are subject to failure as a result of frequent empty operation or flow blockage. Why trap drain systems that allow property damage and health threats are so widely used and unchallenged is explainable. The condensate drain system is a unique component in the total system. It is an interface between the drain pan connection and the facility drain system, for which no entity accepts responsibility for its operation or failures. Hence, there is little interest in improving drain system performance. The building owners and managers are the victims, while others stand to gain in the form of more service calls and higher than necessary equipment replacement rates. The consequences of trap evaporation and flow blockage are unseen by the casual observer, but they can be illustrated vividly using laboratory simulated air handlers with transparent panels. These simulators allow building owners and other concerned parties to see and understand how trap failures cause damage and contamination to their air handlers and buildings. Just as in a real system, air is drawn through the filter, the cooling coil, across the drain pan, and into the fan. With the best possible trap geometry, the effect of evaporation is illustrated with an empty trap. The laboratory simulator is being operated with a -1 inch of water pressure. Systems are often operated at this or more negative pressures. During startup, after a heating cycle like for summer cooling, trap water is evaporated, allowing air ingestion. Deflection of the benzene lighter flame shows how contaminated air can be drawn into the unit, and the introduction of smoke near the drain outlet shows how polluted air can be drawn into the system and spread into the conditioned space. An empty trap allows the ingestion of outside air during winter or non-cooling operation until condensate fills the trap. The two views show the blowing of condensate as the drain pan fills. Now, at 1.5 inches of water, condensate blowing becomes intense. Flow cannot occur at this pressure because water will overflow from the drain pan before drainage can begin. Also, as shown by paper placed in the blower airstream, water particles can be carried into the ductwork and cause damage to insulation and other components. Debris and algae growth frequently block traps as shown here and cause drain pan overflow, a common cause of building property damage and contamination. Condensate traps exposed to freezing temperatures can become blocked by ice, causing drain pan overflow. When freezing occurs, traps can become ruptured as depicted here and act like an empty trap, allowing air ingestion and condensate blowing during the cooling operation. The consequences of trap failures, including those just demonstrated with laboratory simulators, are summarized here. High-velocity air entering through failed traps can blow condensate into the system and ductwork. In addition, high negative pressure or flow blockage can cause the drain pan to overflow. These events cause damage to the air handler and the building, creating a perpetual internal wetness, a fertile growth place for mold, bacteria, and other health-threatening biological contaminants. The property damage and maintenance effort required for this type system eliminates any hope for low life cycle cost. Further, since all the air inside a building may pass through the contaminated air handler several times per hour, health-threatening conditions are virtually certain. Thus, the use of systems equipped with condensate traps in reality rules out the realization of low HVAC operating cost in healthy building environments. A trap is an integral part of most condensate drain systems. Frequent trap failures impose severe property damage and health threats on building owners and occupants. Aside from building owners and managers, there is little concern about trap failures and the damages they cause. The reason is clear. The drain system is a unique component. It is an interface between the drain pan and the building drain system, for which no entity is responsible. The only victims are the building owners and occupants. Others may gain from service calls and shortened equipment life. There is, however, a proven advanced technology drain system that eliminates all trap drain system problems. The only known successful alternative to the condensate trap is the CostGard Condensate Drain Seal, a proven, reliable, advanced technology drain system that uses an air seal instead of a water seal, eliminating all the problems associated with the industry standard drain system. It provides a seal during all operating conditions, both heating and cooling, and in any climate. It is self-cleaning, self-regulating, and requires no maintenance. This seal protects the building owner or user against undue cost in terms of maintenance effort, property damage, early equipment replacement, and health care. For this reason, the word CostGard is used to identify this seal. How the CostGard Condensate Drain Seal functions can easily be explained by the use of a simulated air handler. A small quantity of air is taken from the positive pressure side of the fan. A portion of this air is discharged through the condensate drain pipe to ensure that outside air and pollutants are not drawn into the system. The remainder of the air is directed through the mitered elbows into the air conditioning unit. The air pressure loss in these elbows ensures that the air velocity entering the condensate drain pan is too low to cause condensate blowing. At the same time, its air seal allows condensate to flow freely from the drain pan. CostGard condensate drain seals will operate successfully with internal negative pressures of 5 inches of water. The CostGard device being demonstrated here is operating at a negative pressure of 1.5 inches of water, typical of air conditioning systems up to 30 tons. Note the two views. Observe that there is no blowing of condensate and that flow discharge is smooth. Note also that the benzene lighter flame is being blown away, thus air and pollutants cannot enter through the drain connection. Perhaps the most recognized problem with a condensate trap is that it catches debris and becomes blocked. This happens frequently, often after only a few months of operation. The CostGard condensate drain seal inherently guards against such blockage. This special CostGard device, equipped with clear plastic elbows, shows why. Here, soggy oatmeal is used to simulate the slime that often clogs drain lines and traps. Note the churning action produced by the air entering the device and the rapid passage of the debris. Unlike the condensate trap, the CostGard condensate drain seal retains no condensate and is unaffected by freezing temperatures that destroy traps. During the cooling operation, when condensate is being generated, it flows rapidly through the drain seal, including the mitered elbows. Once condensate flow ceases, the warmer air that forms the drain seal quickly evaporates any water that may be held inside by surface tension. With the aid of front and rear transparent panels, the effectiveness of the CostGard condensate drain seal system in preventing the blowing of condensate in a small fan coil unit operating at negative 0.6 inches of water column versus a trap is shown here. See the ingestion of air through the empty trap as the drain pan fills, and the blowing of condensate from the drain port back into the unit. Now, with the CostGard condensate drain seal system, note that there is no condensate blowing, and condensate flows smoothly through the device. A key feature of the CostGard condensate drain seal is that it uses an air seal in place of a water seal, and therefore prevents the problems caused by condensate traps. It eliminates the ingestion of noxious and toxic gases through the condensate drain line, the blowing of condensate by air entering the drain connection, flooding caused by excessive negative pressure or trap blockage, and it precludes the possibility of seal destruction by freezing temperatures. It is simple, has no moving parts, it is self-cleaning, self-regulating, and virtually maintenance-free. And it costs less than a typical service call to clean a trap, not including the damage caused by the trap failure. These features of the CostGard Condensate Drain Seal offer building owners numerous benefits. Reduced life cycle cost by decreasing maintenance effort, equipment corrosion and damage to the building and contents, and improved environmental conditions by limiting system internal wetness that promotes the growth of health-threatening biological contaminants. These photographs compare the internal conditions of air handlers with and without the CostGard Condensate Drain Seal. The differences are clear. The top photographs with the industry standard drain system were in operation for less than 10 years. Failed condensate drain systems led to these wet and dirty conditions, building damage and poor indoor air quality. In contrast, the bottom photographs show units that use the CostGard Condensate Drain Seal operating for more than 13 years with no preventive maintenance. As you can see, the units are clean and dry inside, offering the owner many years of extended service. CostGard Condensate Drain Seals are applicable to any draw-through air conditioner, unitary or split, with cooling capacities to over 100 tons, drain sizes 3/4 inch to 2 inches in diameter, drain pan pressures to a negative 5 inches of water, both indoor and outdoor locations, all kinds of climates, hot and humid to cold and dry. The CostGard Condensate Drain Seal system has been operating successfully in various applications for more than 20 years. These systems are exposed to a wide range of geographical and environmental conditions, extending from Puerto Rico to Alaska, from Maine to Hawaii, and every state in the United States, including the District of Columbia. Some current users of CostGard Condensate Drain Seal systems are listed here, and include commercial and public buildings, schools and universities, and medical facilities. The commonality among these building owners is that they have competent technical support and are well-qualified maintenance personnel, each committed to achieving buildings with low life cycle cost and healthy indoor environments. Users' comments on the performance of the CostGard Condensate Drain Seal are typified by an internal e-letter from a Walgreens maintenance person. It reads, "Howard, in the years we've been getting the RTUs with the Trent CostGard drains on them, the evaporators are the cleanest we have ever seen them. Nothing like the old-style trap that just clogged up in summer and froze in wintertime, and that has helped to eliminate calls regarding water flowing back into the stores. They truly are paying for themselves." Walgreens now has more than 8,000 stores equipped with CostGard Condensate Drain Seals, a significant step towards lowering building operating cost and healthy indoor environments. CostGard Condensate Drain Seals are designed to match any type manufacturer's unit and are available in 3 different kits: a fan coil basic kit, custom kit, and a rooftop system kit. Fan coil basic kits include all non-standard components needed for installation and are suitable for unitary and split system air handlers up to 30 tons, with drain pan pressures to a negative 1 1/2 inches of water column, and are available in 3/4 inch and 1 inch drain sizes. Custom kits include all non-standard components needed for installation and are suitable for larger unitary and split system air handlers from 30 tons to over 100 tons, with drain pan pressures to a negative 5 inches of water column, and are available in 3/4 inch, 1 inch, 1 1/4 inch, 1 1/2 inch, and 2 inch drain sizes. Rooftop system kits include all components needed for installation and are available for over 500 Carrier, Train, Lennox, and York rooftop models up to 30 tons, with drain pan pressures to a negative 1 1/2 inches of water column, and are available in 3/4 inch, 1 inch, and 1.5 inch drain sizes. And all components are UV inhibited. In summary, the CostGard Condensate Drain Seal is a widely used, effective, reliable, and practical means for draining condensate from draw-through air conditioning systems. Low HVAC operating cost and healthy building environments are not possible unless equipped with properly drained air handlers. Building owners and managers can ensure their buildings are not unnecessarily compromised by air handlers by simply instructing designers and/or builders to equip all draw-through air conditioning systems with CostGard condensate drain seals.